Find the derivative of y equals 1 over f of x, then evaluate y prime of 0, where f of 0 is negative 3 and f prime of 0 is negative 6. So y here is the quotient of two expressions, a 1 divided by f of x. Since the numerator is a constant, we can move the denominator up, and it will multiply the 1 by writing it as a negative exponent, a negative first power. So this could also be written as f of x to the negative 1 power. So we have a composition of functions because we have the f of x, which is an unknown function, inside of the negative 1 power. The negative 1 power is the outermost function here. That means we have a chain rule for the derivative. Y prime, or dy dx, equals, we start with the power rule, the outermost function, bring down the power, leave the inside alone, subtract 1 from the power, that'll give us a negative 2 power, and then multiply by the derivative of the inside for the chain rule, so that will be called f prime of x. Let's take a step and rewrite this. Let's move that negative exponent back to the denominator, and then the numerator will be made up of a negative 1 and an f prime of x. Those will not move, so we will have a negative f prime of x, and all over the f of x will move to the denominator and become a positive exponent squared. So there's our derivative y prime, or dy dx. The next thing to do is evaluate y prime of 0. And that means to plug a 0 in for the x's, so we will have negative f prime of 0 divided by f of 0 quantity squared. F prime of 0 and f of 0, we will look those up. They are here in the information given. So f prime of 0 is a negative 6, and f of 0 is a negative 3. So we have, well, I'm going to multiply this negative with that negative, and we will end up with a positive 6. And in the denominator, I have negative 3 squared. Negative 3 times negative 3 is a positive 9. 6 over 9, these are reducible by 3. Divide by 3 from each, and we end up with 2 over 3.